Okay, so in this video we're gonna talk about the imaginary numbers. Let's start by introducing the imaginary unit, the I. Okay, consider this quadratic equation: x squared plus 1 equals 0. Now to solve for x, we can subtract 1 both sides, and if we do that, we'll end up with x squared equals -1. Now to get x by itself, we're going to have to take the square root on both sides, and then don't forget the plus or minus, and that gives us x equals plus or minus the square root of -1. Now this is interesting because there's no real number that if you square it will give you -1. So for example, if we try 1 times a 1, so if we square 1, we'll get +1 back. Now what if we try -1? Well, -1 times a -1 is also a +1. So there's no real number that if you square it or multiply by itself, that's going to give us a -1 as an answer. So for this reason, the imaginary numbers was created. Okay, so we define the imaginary number I to be equal to the square root of -1, or what's the same thing is I is a number so that if you square it, you'll end up with a -1. These two things are equivalent. So if we define our I this way, then the solution to this equation is going to be plus or minus I. Okay, so this I right here is called the imaginary unit. Its role is the same as that of our real unit, 1, so that's for the real numbers. I would be the unit for the imaginary numbers. So that's what I is. You just got to remember I is equal to square root of -1, or I squared equals -1. Okay? All right. Let's look at some examples of imaginary numbers. So say you want to know the square root of -4. Well, the square root of -4 is the same as square root of -1 times a 4, because -1 times 4 is -4, and this you can break it down as square root of -1 times the square root of 4. Now by definition, square root of -1 is I, and then square root of 4 is 2, and then we normally write this as 2i. So square root of -4 is 2i. Let's look at another one. Square root of -9. Well, again, -9 is the same as, let me do 9 first this time, 9 times -1, which is, when broken down, the same as square root of 9 times square root of -1. Now square root of 9 is 3, and square root of -1 is I. So you see, taking square root of negative number is going to be really easy once we have this concept of I, the imaginary unit. So in general, a square root of a number x, or let's do -x, so that we're going to be taking square root of negative number, it's going to be whatever the square root of x is times the I. So the I takes care of the negative sign. Okay, let's look at a few more examples. Let's look at a square root of negative number that's not a perfect square. So for example, square root of say we want to do negative 50. Now we're gonna proceed just like we did before, but because 50 is not a perfect square, we're gonna have to have a way to simplify that. So first of all, square root of negative 50, if we do the same as before, is square root of 50 times negative 1, which is good. Now let's also break this 50 into two parts this time, and it could be more than two parts for different numbers, such that one of the factor is a perfect square. So for example, 50 is going to be 25 times a 2, and I've broken it this way because 25 is a perfect square times a negative 1. Okay, so now this is the same as a square root of 25 times 2. I'm going to group this together, times a square root of negative 1. Now here, square root of 25 is 5. Square root of 2, well, it doesn't simplify further, so I'm just going to have 5 square root of 2 there. And then square root of negative 1, by definition, is I. Okay? Similarly, let's do one more example. If I want to know the square root of, let's say, negative 45, then realize that negative 45 is the same as 9 times 5 times a negative 1. Now again, I've broken 45 as 9 times 5 because 9 is a perfect square. So this is the same as the square root of 9 times 5 times the square root of negative 1. Now here, square root of 9 is a 3, so this is going to be simplified as 3 square root of 5. Remember, 5 is by itself, and then square root of negative 1 is I. Okay, so with the introduction of this imaginary unit I, we'll be able to write the square roots, or as a matter of fact, any even root like fourth roots or sixth roots of negative number in terms of i's. All right, the last thing we're gonna talk about in this video is gonna be powers of I. So first of all, I raised to the first power is just gonna be I. Now I squared, again, remember the definition says I squared is negative 1. But what about I cubed? Well, I cubed is the same as I squared times I, right? Well, I squared is negative 1 times an I is negative I. What about I to the fourth power? Well, I to the fourth power is the same as I squared squared. Now we know I squared is negative 1, and then if I square negative 1, I'll get 1 back. And this is going to be the pattern that the powers of i's are going to follow. I, negative 1, negative I, and 1. Now if I do I to the fifth power, I'm going to get back to just I. Okay, so let me just show you that. So I to the fifth power is I to the fourth power times I. And then here we just found out that I to the fourth power is 1 times I, which is just going to be I. Now in general, if I want to know a power of I, for example, say let's see if I can figure out what I to the power 20 is. What I want to do is I want to write this as some powers of I squared. Then maybe if this is odd, I'll have additional I lying around. Okay, so what do I mean by that? So for example, I to the power 20 is the same as I squared raised to power 10, right? So 2 times 10 is 20. Now, we'll list the fact that I squared is negative 1. Again, that's the definition. So this is going to be negative 1 to the power 10. Now, this just means we're multiplying negative 1 10 times. Now, if you multiply negative 1 even number of times, So let's start with -1 times -1. It's a +1. If I do -1 times -1 times -1 times -1 4 times, again, the first two -1s will give me +1. Next two -1s multiplied together would give me +1. So the end result would be +1. So -1 to the power 10 ends up being a 1, which means I to the power 20 is 1. Okay, so it's important to kind of remember this fact in your mind. So if I raise -1 to the even power, like 10, 12, 24, whatever, I'll get 1 back. And if I raise -1 to the odd power, like -1 cubed or -1/7, whatever, I'll end up with a -1. Okay, so if you remember this, is going to be very, very helpful. Okay, so finally, let's do an example for odd power of I. So for example, if I want to know what I to the power 21 is, so first of all, 21 is not an even, so I cannot write I to the power 21 as a power of I squared. But what I can do is I can write I to the 20th power as the power of I squared. So now this gives me I to the power 20, 2 times 10, just like we did up here. But now I need an additional I, so I'm going to just write that additional I on the side here. Okay, so now because we know I squared is -1, and rewrite this as -1 to the 10th power times an I. Now -1 to the 10th power, 10 being even, makes this a +1. And then I've got a times I here, and then 1 times I is going to be I. So this is how we can evaluate different powers of I. And no matter what power of I you're dealing with, you're always going to get one of these four answers. You're either going to get I, -1, -I, or 1. That's it for this lesson. Thanks for watching.